In this problem, we're asked to find the steady state response V0 SS of t. We can see the circuit. We've got a cosine for a source, and the way we'll approach this is we're going to draw the S-domain circuit, do our analysis in the S-domain, and find the transfer function which relates V0 to this current source. So first, let's draw the S-domain circuit, and here that circuit is. I've called the current source for now I sub I of S, and what we're looking for is the transfer function which relates V0 of S and I sub I of S. Now we could do a number of techniques. What we'll do here is I'm going to do nodal analysis, and if I look, I'm going to pick this as a reference node. Now there's a node here that's V0, and then there's another node here. I'm going to call that VI. And what I'm going to do is I'm going to use nodal analysis to find VI, and then V0 is just a voltage divider. So let's use nodal analysis to find VI. And once I have VI, then I can just use voltage division. So I'm going to apply KCL at this node. So if we do that, we'll have V sub I divided by 4 plus 4 over S. That's the current leaving through here. Then we have V sub I over S. That's the current leaving through here. Then we have V sub I over S over 2 plus 4 over S. That's the current leaving through there. And then this is going to be equal to minus I sub I of S. Because that current, we're looking for currents entering, that current's actually leaving. So there's our nodal equation to find VI. So if we start working on this algebraically, VI then is S over 4S plus 4 plus 1 over S plus S over 2S plus 4 is equal to minus I sub I. Now, if we work on this algebraically, VI times 6S cubed plus 16S squared plus 24S plus 16 over S times 4S plus 4 times 2S plus 4 is equal to minus I sub I. Okay, so then VI is S times 4S plus 4 times 2S plus 4 over 6S cubed plus 16S squared plus 24S plus 16 times minus I sub I. So now we have a relationship between V sub I and I sub I. Now if we go back to our circuit, now this V0, this is just a voltage divider. So V0 then is 4 over S over 2 plus 4 over S times VI. Okay. So we want the voltage here, so we put this in the top and those two in the denominator. So then V0 is 4 over 2S plus 4 times VI. Now we can substitute in this expression in for here. So when we do that, we'll have V0 is 4 over 2S plus 4 times S times 4S plus 4 times 2S plus 4 over 6s cubed plus 16s squared plus 24s plus 16 times minus I sub I of s. Now if we look, for instance, now these two terms cancel out, and certainly we can factor a 2 out down here and use that to cancel out a 2 up there. So if we rewrite this as 2 times 3s cubed plus 8s squared plus 12s plus 8, then we could cancel a 2 out down there, and then v0 then is minus 8s times s plus 1 over 3s cubed plus 8s squared plus 12s plus 8 times I sub I. Now, this quantity here is h of s. And now what we need to do is we go back to our source was cosine 2t. We now need to evaluate h of s at s equal j2. That's how we'll find our steady state response. So h of j2 then is minus 8 times j2 plus 1 over 3 times j2 cubed plus 8 times j2 squared plus 12 times j2 plus 8, and that's 1.49 at an angle of 153.43. So now v0 ss of t, and remember our current source had a value of 2, so it's going to be 2 times 1.49 times the cosine of 2t plus 153.43. That'll be 2.98 cosine 2t plus 153.43 volts.